Mark your attendance. First, mark your attendance. Can I stop sharing now? I hope you all mark your attendance.
Yes, ma'am.
Now moving to our question. Bending moment is equivalent to MR. Bending moment we already calculate 111.937, right? Kilonewton meter. Then what is the formula for moment of resistance? First, you tell me moment of resistance formula for compression and moment of resistance formula for tension. Sonu Kumar Gupta, last time. Moment of resistance formula for compression zone. Sonu Kumar Gupta. Right. Sonu Kumar Gupta, what is the formula for moment of resistance for compression zone? Are you hearing me or not? सोनू कुमार गुप्ता, then now I remove you from here. मैम आवाज नहीं आ रहा जा रहा है। आवाज कैसे नहीं आ रही है? कैलाश कुमार, what is the formula for moment of resistance for compression zone? कैलाश कुमार, कैलाश कुमार, सोनू कुमार गुप्ता एंड कैलाश कुमार। चलो सबके अटेंडेंस अभी काटते मैं जा रही हूँ। अटेंडेंस भी मैंने खोला हुआ है। ओके मैम, यहाँ पर नेटवर्क नहीं है। कैलाश कुमार, गायब। ओके रितेश कुमार, रितेश,
Yes, ma'am.
what is the formula for moment of resistance?
Total uh, in compression, ma'am. Total compression into lever arm. That is
Total compression into lever arm, right?
yes, ma'am.
Then what is the formula for total compression and lever arm?
1/2 into sigma CBC into B into N, and lever arm is D minus N by 3.
D minus N by
3.
right? Okay. Smriti, what is the formula for moment of resistance for tension zone? Smriti, Smriti, what is the formula for moment of resistance for tension zone? Okay, means कैलाश कुमार एंड स्मृति। आज इन लोगों का अटेंडेंस मैं कट कर रही हूँ। रिमूव कर जाओ स्मृति, रिमूव कर जाओ, यहाँ बैठने से कोई फायदा नहीं है। Pabli Kumari, what is the formula for moment of resistance?
Ma'am, tensile force into lever arm. That is T into area of steel into D minus N by 3.
Repeat again. Repeat again. Gaia. Okay. चलो means bending moment of resistance is equivalent to, then calculate 37 into half into B into C into N into D minus N by 3. Kilonewton meter. And B is in mm, N is in mm here, D is in mm here, and again N is in mm here. That's why we convert bending moment into Newton meter Newton mm. For this, we have to multiply bending moment into 10 to the power 6. Then put all the values. After putting all the values, we get C is equivalent to
Ma'am, 6.185 square. 185
6.185 Newton. C is compressive stress, then 6.185 Newton per mm square. Or we can write here C is equivalent to 6.20 Newton per mm square. Right? Means in compression zone, the stress acting on concrete is equivalent to 6.20. Similarly, we have to find out the stresses in steel. For this, T by N is equivalent to T by M divided by T minus N. Here, we know the value of T, N, D, and M. Then by putting all these values, we get the value of T here. And you put all the values and calculate. C is 6.20 and the value of N is 230. Sorry, I forget the value of N.
230.64 ma'am.
230.64. Okay. C is equivalent to 6.20. N is 230.64. M is 11. And D is 650 minus 50 is 600 mm. Now put all the values and calculate the value of T.
One 108.979 Newton.
One zero
Bending moment को से
108. Sorry, due to poor network again. No. After solving, we get the value of T is 108.979. 979 Newton per mm square.
मैम मेरा आ रहा है 109.216 न्यूटन पर एमएम स्क्वायर।
109.216
यस मैम, न्यूटन पर एमएम
पर mm स्क्वायर। किसी और
Yes.
का वेरी कर रहे हैं?
मैम 109.21
109.21 Wait first, calculate that. What is the value of D? D is 600 minus N is 230.64, right? Into value of M is 11 into value of C is 6.20, right? Divided by value of N, 230.64, 109.21935. It means
मैम n इक्वल टू लिए हैं 230.644 और आप ले लिए हैं 230.641।
tell me again, the value of N is 230.644.
644।
Okay. बहुत वेरी नहीं करेगा, means the value of T becomes 109.21 Newton per mm square. Means 109.2 और 0.2 के बाद हो सकता है वेरी करे 0.23, मे बी 0.21, मे बी 0.25। ओके, तो हो सकता है ये वेरी करे। Means we have the value of C and T means part 1 is completed and the second part of question is find the maximum moment carrying capacity of the beam. Then the maximum moment carrying capacity of the beam for a balanced section. Is Bm is equivalent to Mr. And Mr is the moment resistance capacity of the beam. Means we have also Mr is equivalent to 1.937 kilonewton meter in case of balance condition. Right? Now, if you want to find out the beam section, if beam section is under reinforced or beam section is over reinforced, then you have to calculate NC. And then you compare N and NC value. Right? Then you will be able to find out the section is under reinforced and over reinforced. But for a balanced condition, we already calculate the maximum moment carrying capacity of the beam section. So the part 2 is completed for a balance section. For a balance section only. If our beam section is under reinforced, then we have to find out again NC. And if the beam section is over reinforced, then again we have to find out NC. And then we compare bending moment with moment of resistance. Okay. Now, moving to our next question. The next question is, calculate 1 minute. Calculate the MR of the section. Calculate the MR of the section okay. Beam of triangular section. Okay. Calculate the MR of the section वन मिनट की क्वेश्चन उठा लेते हैं कहीं से भी Question is calculate MR of the beam section if beam is inverted and reinforcement is provided at the apex, right? If the beam is inverted if the beam is inverted and reinforcement is provided at the apex. This question is from DC Punamiya book. At the apex, also determine the reinforcement and moment of resistance corresponding to the balance section. This question is tricky. Okay, and figure is included in this question or given in this question, and the figure is like, according to question, the beam is inverted, means our triangular shaped beam is inverted, ulta hai, and the reinforcement is provided at the apex. Apex means इसके top में provided है. Then here reinforcement provided is 1, 2, 3, and 4. Means 4 reinforcement of 16 mm dia is provided at the apex of the beam. Means we have a triangular beam, triangular inverted beam, and 4 bar of 16 mm dia reinforcement is provided at the apex, right? And also in figure, this is your neutral axis, NA, right? And the distance between these 2 points is given B0 . This value is your width of the beam. B is equivalent to 300 mm. And अभी मैं इसे delete करती हूँ. बहुत and overall depth of the beam is overall effective depth of beam is D is equivalent to 600 and effective cover provided is 50 mm. In that case, you have to find out the moment of resistance of the beam section and also again determine the reinforcement and moment of resistance of the balance section. First, we have to find out moment of resistance of this section. Then we calculate the MR and AST of the balance section. This question is from BC Punamia book and and use M25 and CE404 steel. In that case, you have to find out the MR of this inverted triangular shape bead. Then how you will start to solve this type of question? You have any idea or not? How to solve this type of tricky question?
No, ma'am.
First, draw the beam section and put all the values. And then start assuming the CG of reinforcement, the CG of reinforcement which is 0 means this is your inverted triangular shape beam and CG of this reinforcement. CG width of this reinforcement is B. This is noted here beam 300 mm, which is given in the question, and the width of the CG of the reinforcement here B is equivalent to 0. First, assume the CG, the width at the CG. The width at the CG means here the value of B is equivalent to 0. Okay, then find out AST, which is provided at the bottom or apex of the apex means Here we provide 4 bars.